these are the components that we need for our developing and etching. This is our etching kit as described in the previous video. Today we will be showing how to mix the chemicals in their correct ratios. Please, all the chemicals are dangerous chemicals. You do not want to mess these chemicals on yourself. If you do, the first thing you want to do is get to water. Please guys, be safe and be wise when you do this. Don't be foolish. So yeah, let us proceed. Okay, first things first, what we've got here is we've got our gloves on. Guys, like I said, always be safe. Don't be foolish with this. Never think for whatever reason you are able to beat the system. Sometimes spilling is inevitable, so please let's be cautious with working with chemicals. Right, anyway, first things first. What we're doing is I'm going to decanter some of the distilled water into a smaller container. It's never really a good idea to use such a big container to pour into smaller containers. You tend to get splashing and that type of stuff, and you tend to spill. So using the smaller one, we will obviously get ourselves ahead of the game. Right, so what we're doing is we're going to be doing 500 milliliters of distilled water. Always a good idea also, never pour, let me just try and illustrate this. Never pour upright. You'll always mess. Turn the can a little bit to the side. It brings the flow of liquid to a better level. As you can see, it's more controlled. Right, let us do that. That's 500 mils. That's what we're going to be using for our first mix. Right, what we've got here, we've got our 500 mils of distilled water, which we just decanted. We've got our 20 grams of caustic soda. This is sufficient to mix up 5 solutions of developer. So we'll only be using 4 grams of caustic soda to mix up the solution. I've got a small jewelry type scale for weighing these type of things. It doesn't measure large quantities, but it's extremely accurate on lower quantities. That's why I chose this. This is our measuring beaker, and I've got a plastic mixing spoon. I'll not be using the beaker for this particular measurement. If we were decantering from a different quantity or size jug, I would then recommend using this. However, we need 500 milliliters of distilled water for this particular solution. We've got 500 mils inside this measuring cup, so I'm going to push this to the side. We do not need that at the moment. Right, first thing is what we're going to do is we obviously want to put our chemical into the lid. So let's just scale on and 0. Very cautiously, let's measure out our quantity that we require. Right, we got 1, 2 grams, 2.4, 2.5, 3 grams, 3.2, and there we have it. We are at 4 grams. Right. If you have a measuring scale which is also accurate, we read 2 zeros after the decimal. If you're at 4.05 or 4.1, it's not critical. Again, with the 500 mils of distilled water. If it's 490, 510, it's not really going to influence what's going on. The measurements have got a bit of tolerance on it, so it's not a deadly critical. Right. There. Take it off, out the way. Right, so what we're doing here is we're going to be adding the water into the tub first. They reckon always add chemicals to water and never the other way around. So we'll try and stick to some good practice here. There we go, our water is in. And now to add the caustic soda. Just give it a gentle sprinkle until you've got a bit of a layer at the bottom. You don't have to mix all of it at the same time. It tends to create a bit of clutter. Gently just swirl it. Don't be rough with it, you don't want to mess. Again, if you do happen to mess the solution on you, it's not a matter of call emergency services. It's not going to eat you up in a matter of seconds. However, you do not want to touch your face or sensitive skin with it. If for whatever reason you do, just make sure you get to some clean running water and wash yourself down. Right, always close stuff that you're not busy with to avoid spill and also for safety. The distilled water doesn't have to be heated in any way whatsoever. Room temperature is more than adequate. I do not recommend refrigerating it for dissolving purposes. Obviously warmer water always works better, and like I said, room temperature is more than adequate. The caustic soda actually dissolves quite nicely. It's not stubborn in any way. Right, there we go. Okay, what we want to do with this is obviously we want to close it. I like to keep my spoon in a container. Right, there we go. Right, so this is done. Let's get this out the way and let's get the next one on the table. Okay, what we're mixing here now is our etching solution. We've got hydrochloric acid at 30% volume. We've got our hydrogen peroxide at a 50% volume. I've got 500 moles of distilled water which are decanted into the bottle. It makes it easier to put into our measuring beaker, and I have then got our plastic spoon which we've rinsed, which we will be using again for this application. Right, again, we don't want to add water to chemicals, we rather want to add chemicals to water. So what we will be doing is, for this particular solution, we will be using 2 50 milliliter measurements of hydrochloric acid, which is 100 mils. We will be using 50 mils of hydrogen peroxide, 1 measurement, and we'll be using 4 measurements of distilled water. So what I'm going to do is I'm going to add 3 measurements of water to the bowl to start with, then hydrochloric acid. I will then use distilled water again in our measuring beaker, which will then rinse the beaker, put that in, and then we'll add the hydrogen peroxide, so that all of our things are always clean. Right, let's get started with this. Again, I like to use the lids for the boxes as a spill protection, or if you just happen to dribble down the side, it tends to land on the plastic, which the chemical is not corrosive to the plastic, so always good to use for for that type of thing. Right, and we've got our first 50 ml of water. Add that in. Again, the measurements are not super critical. There is a little bit of a tolerance, so if you tend to get a little under 50 or a little over 50, not entirely critical. The solution does work. If you go very wrong with it, then you'll be having other drama. You might be having an excessively strong etchant, which will eat away all of the copper in seconds flat without you even knowing it. Right, so there we go. We've got 3 of those in distilled water. Right, let's just close that. We don't want to miss any of that. Right, next up is our hydrochloric. The other important thing with this lot is to obviously do this in a well ventilated area. You don't want to do this in a closed environment. These things are toxic, and you do not want to be breathing them in. And guys, please remember your gloves. Do not remove your gloves for any reason other than the fact if they have got a slight hole or something, then change your gloves. Again, don't risk it. Don't tempt fate. Right, here we go. 100 milliliters of hydrochloric acid. Right, close the bottle up. Okay, and next we will be one of those to rinse our beaker out. You can do a proper rinse down if you wish. Again, not totally critical. What we've done here is sufficient. Hydrogen peroxide. Again, this you do not want to mess on yourself. This here tends to flake away your skin. You don't feel it, it doesn't burn. Your skin flakes away. It's really not a nice thing to mess on yourself. So again, handle with absolute caution. Again, working with chemicals, guys, please make sure that these things are stored in a place out of reach of children, locked away, and preferably out of sight. Definitely safety first. This liquid is clear liquid, as you see, and small kids can easily mistake this for water, and out of curiosity they can open drink it. It's got a relatively foul smell to it, so I don't believe it will get to their mouth. Again, we don't tempt fate. Right, and this we add into the solution. Right, what we will have here now is that this here will start bubbling, almost like soda. The water, or the solution in actual fact, would still remain visibly clear. Right, let's just give this a little bit of a swirl. Right, we can give this a second. Right, and immediately at the bottom of the container it starts building up small little bubbles. Like I said, it starts fizzing like soda water. However, it isn't. Okay, give it a little bit of a stir. Right, and there we go. There is our etching solution. It's mixed and it is ready for use. Right, let's close this lot up, and we'll see you back at the next video.